So the quiz on Monday is going to look just like this. Okay. So if you can do this, you're ready for the quiz. I apologize if your PDF, the the lines might have shifted when it converted it to a PDF. So if your graphs are not quite on the lines where they belong, I'm sorry. So so this is in Google Classroom. If you don't do it, if you do it on paper, just take a picture of it so that you can submit it. Let's take a look at these first ones. We're going to be using the 4 functions that you see there. So f of x, g of x, h of x, and j of x. So remember, let's start with our first one. G of f is the same of the g function, plug in f. So all we're going to do is we are going to take our g function and we are going to plug in the square root of x minus 2. Now remember, it replaces the x in the g function. So take the x placement in the g function and put a parenthesis, and that's where you place, in this case, the square root. Now, please simplify it as much as you possibly can. So following order of operations, we would square that square root. So it would just pop off there. And so it would be 3 times the quantity of x minus 2 minus 1, which is 3x minus 6 minus 1 for a final answer of 3x minus 7. So just simplify it down as much as you can. If you can't simplify much, don't. Do what you can. Everybody okay with what I did for number 1? Just function stuff. Now let's take a look at number 2, j of h. We're going to take the j function and we're going to plug in h. So our h function is 2x minus 7. So what I like to do is I like to actually just put in 2x minus 7. Then I don't have to think about what needs to go in there. So that's going to go into our into our j function. It's going to go right there. So it's going to be 1 over our input plus 2. So it's going to be 1 over our input plus 2. Now, we can't do much for this function. 2x minus 7 plus 2 just can be simplified just slightly. So your final answer would be 1 over 2x minus 5. So just follow order of operations, simplify as much as you can, then stop. Okay. And then for our last function composition is a 3-layer function composition. So we're going to take our f function. Inside of that, we're going to put our g function. Inside of that, we're going to put our h function. So my suggestion to you is to work from the inside out. So we might ignore some of the outer layers until we have dealt with the inside. Now remember, h of x is 2x minus 7. So I'm just going to write the 2x minus 7 right there, so then I don't have to worry about it anymore. Okay, and then I'm only going to go 1 layer out, so I'm just going to plug that into my g function. So that's going to go into the g function. Okay. When I plug that into the g function, I get 3 times the quantity of 2x minus 7 squared minus 1. 3 times the quantity. Let me make that look a little nicer. of 2x minus squared, 2x minus 7 squared. Now, I am not going to do anything with my f function. I'm going to ignore it until I get this to be a little nicer. Okay. So let's ignore the f still. And let's do out that 2x minus 7 squared. Now remember, following order of operations, the 3 is just going to wait for us. We're going to do 2x minus 7 times 2x minus 7. When you do that, you get 4x squared minus 28x plus 49. And then let's distribute the 3 again. The f I don't even care about right now. And when I distribute the 3, I get 12x squared. And then 3 times negative 28 is negative 84. And then 49 times 3 is 147. And again, I'm not ready to do anything yet with the f until I make that as simplified as possible. So it's going to be 12x squared minus 84x plus 146. Only now am I ready to go and plug that into my f function. So get it simplified as much as you can before you go any further. Now the f function is the square root of x minus 2. I am not going to do much with that. Okay, it's going to be the square root of that thing minus 2. So if you look at your f function, we're just going to put that gross polynomial right there, and we're going to minus 2. And just because for room's sake, so we have enough room, the final answer would be the square root of 12x squared minus 84x. Now it would be plus 146 minus 2, right? Because it has that minus 2 there. So it would be plus 144. Now you can't take the square root of that unless it was a perfect square. It is not a perfect square. There's no perfect square I can remove. Well, I mean, they're all divisible by 4, so I mean, I could if I really wanted to. We subtracted 2 from it. If you looked at our original f function, it is whatever we input, take off 2. And so I did that in one step just because I didn't have room. Okay. I'm sorry? You can't take the square root of the pieces. It is the square root of the entire answer. And so until we knew what x was and we knew what the entire answer was, unfortunately, we can't reduce it down, change it. Like I said, every piece is divisible by 4. We could probably reduce it that way, but I'm okay with you just leaving it where we're at. Okay, so does anybody have any questions about the composition ones? We okay with those ones? Okay. Now let's talk about domain. So then let's do number 4. So they want the domain of each. So I'm going to put the domain of f, and I'm going to put just a little f next to the D for domain, just because then you can clearly see what the heck I was talking about. Remember, for a square root function, the inside has to be greater than or equal to 0. So we're really just thinking, where does that f function have an inside that's greater than or equal to 0, because it's a square root function. And then if you solve that, wouldn't you get that x is greater than or equal to 2? Okay, so that gives us x is greater than or equal to 2. Now, if you wrote down x is greater than or equal to 2, that's the domain. You know, I'm going to give it to you. But I prefer that we write it in interval notation. So it's going to go from 2 to infinity. Okay, so that's the domain of f. G is nice. G is a polynomial. I can plug in any number I want into G. So the domain of G is all real numbers from negative infinity to positive infinity. If you wanted to make that double-backed R for all real numbers, that symbol for all real numbers, go for it. That's perfectly fine. I don't care. H is another polynomial. So the domain of H is, again, all real numbers. You can go negative infinity to positive infinity, or the double-back R is okay by me. Don't care. Whatever you want to do. Finally, we have J. So you'll notice that the ones that cause you issue in domain is square roots and fractions. So we have a fraction for J. So J, we have to worry about the fact, and let me kind of go under here, that x plus 2 is not allowed to equal 0. So whatever value gives me a 0, I have to skip that over. So we know that x is not allowed to equal negative 2. Now, if you tell me x is not allowed to equal negative 2, I'm going to give it to you. Again, I prefer interval notation. So the domain of J is kind of a long one. We have to skip over a value of negative 2. We just got to jump across that, because remember, there's an asymptote there. So we're going to go from negative infinity up to negative 2. We're going to leap across it, and then we're going to keep going forever and ever and ever. The only value that does not work for that fractional function is the value negative 2. Okay? So those are domains. So the beginning of the quiz, I am going to give you 4 functions. You are going to compose them. You are going to simplify that as much as possible. And then you also are going to find domains. Okay. Does anybody have any questions about the first 4 problems? Okay. Should be review, hopefully. Now, your graph paper might be a little wonky, so you may have to adjust where it hits, or maybe mark what your values are, because my graph, does your graph paper, is it a little offline? Yeah, I'm sorry. So I'm going to give you a second if you want to kind of adjust your graph paper a little bit so that you can see it a little nicer, so that it lines up with the points that are showing on mine. On your quiz, it's going to line up perfectly fine. On the quiz, I did set it up that the G function I drew on the top and the F function is on the bottom. So when you look at the quiz, that is kind of what happened for the graph. The G function is the top pieces, and the F, because I can't really color code it on the quiz. I guess maybe I could, and maybe I'll play with it. Anyway, so remember to find a function value from a graph. In this case, G of 2. Let's look, and I'll show you what your graph paper was meant to say. Okay, so we're going to go over to an x value of 2. We're going to go up to our G function, and then if you count, it goes 1, 2, 3, 4. So that point right there on the G function is the point 2, 4. So when you are going to find G of 2, you are finding what is the height on the G function when x is 2. And so because that is the point 2, 4, the answer is 4. And they will be clearly marked on the quiz tomorrow. You shouldn't have to guess where those lines are at. The whole quiz is actually on graph paper, so you'll be able to tell what's what. Now, for 7, remember, like any functional composition, I suggest working yourself from the inside out, okay? So we're going to find G of 1. We're going to get an answer. That answer is what we look for F. Okay, so what is G of 1? Well, if we go to an x value of 1, and if we go up onto the G function, that is the point 1, 5. Okay, so, oh, I skipped one, but we'll get back to it. I'm sorry. So I skipped 6. We'll go back to it. But 7, f of G of 1, G of 1, this value is 5. So we're going to just change that to f of 5. And then we're going to go over to the f function. 1, 2, 3, 4, 5, and look for the f function. Does the f function have a piece that's at 5? No. So when that happens, the final answer would be undefined. Now you can write the word undefined or say null set. That that there are no points that works. So that would be undefined. Okay, so now let's go back to 6 that I skipped. F of 0. We're going to go to our f function. We're going to go to 0, and we're going to look at what's the height. Now, if I have any points, I wanted to show you one that you have to guesstimate. Just guesstimate maybe to the nearest tenth. Doesn't that look to be maybe about 0.3, you think? So 1, 2, I'd say that's about 2.3. So just guesstimate where you think it hits. So on mine, it hits about 2.3. Okay. Let's do another one. Now this time, we are starting with the f function. So if we go on the f function at an x value of 1, what do we use? Do we use this one? Do we use 3? Or do we use 1? We use 3. And why do we use 3? Undefined. Exactly. So if you have an open circle, that's not the one you have to use. So our value is 3. So if we start with the inside, this f of 1 value is 3. So this is next really finding g of 3. So now we go over to our x value of 3, but this time we look on the g function. And the g function, that is the 0.33. So our final answer is 3. Is everybody following where we're getting these values? Okay, work your way from the inside out. Work your way from the inside out. Okay, now for 9 and 10, we are using the f function twice in 9, and 10, we're using the same function again twice. We're going to use the g function. So for number 9, okay, so f of -1 comes first. So start with f of -1. So f of -1, we go over to an x value of -1. We find the f function. So let's say that's 1 point, let's go 1.7. Do you think maybe at 1.7? Okay, so this is going to be f of 1.7. Now we're going to try to find that value on the x, approximate, as close as we can. So 1.7 is about here. No, it isn't. It's about here. And what function of value does f hit? I don't think it probably hits 0. It looks like it's hitting 0. At 1.7, the f function hits a height of 0. So this would be 0. So please just guesstimate as close as you can. If I think the answer is 1.7 and you wrote 1.8, you're good. It's no, just guesstimate as close as you can. And then finally, our last one here, g of -1. So we're going to start at a x value of -1 at looking at the pink g function. So we're going to go to -1. We're going to go up to the g function. And we have to use, just like before, the closed-in dot we see right here, which has a height of 4. Is that right? 1, 2, 3. 1, 2, 3, 4, which has a height of 4. Okay. So what you know is that this is going to be g of 4. So now we're going to go to an x value of 4. 1, 2, 3, 4, and look at our height of our g function. Since that is the 0.42, our answer is 2. So since yours is a little wonky, if anybody wants to take a picture of that one, that you can see the points a little clearer to use as a study guide, here is how we find function values from a graph. Everybody good with that one? Okie dokie. Then the last portion of the graph is, last portion of the quiz is going to cover graphing and symmetry. Okay, so that's the last portion of the graph. So let's go over graphing. Now, I don't care really what method you use to graph these. At least give me 3 points accuracy, minimum of 3 points accuracy. I would like it if you do that. For a square root function, remember the parent function starts at 0, 0, 1, 1, and then 4, 2. Looks like that. Okay. And you can just then shift to those points. What does an x plus 3 do to the function? Where does it shift those points? An x plus 3 shifts the function in what direction? I'm sorry, left. That is correct. If you forget, if you just set x plus 3 equal to 0, we would find that our square root starts to the left of what it should be starting at 0. It starts now at -3. Now, what's great about a square root function, whatever is inside, if you set equal to 0, 1, and 4, you'll find those 3 shifted points. So we're going to go -3. If we set x plus 3 equal to 1, which is the next perfect square, you get -2. And then the next perfect square is 4. So if you set it equal to 4, you get 1. So I would assume those are nice points because those will shift all the x's to the left 3. Now the y's won't change. They'll still be the square root of 0, the square root of 1, and the square root of 4. So you can verify that if you plug those in. But just all of our square root function is going to be shifted to the left. So if we go over here to -3, that's the point -3, 0. And then we're at -2, 1. And then at 1, we're at a height of 2. But look for a second. This is 1 over and 1 up. This is 4 over and 2 up. You know, it's because it's the square root of 1. The square root of 4 is 2, and so on. And then make your square root. So for square root function, I like to set the inside equal to 0, 1, and 4. Get those nice 3 points, and then you're good to go. I am giving you a very simple piecewise function like number 12. We're going to go to an x value of 1. We're going to put a dashed line. Now, the reason we chose an x value of 1 because that's our border values. So we want our border values to show up. So things are happening there. We are switching from one graph to the next at that border. Okay. So the first graph we're going to do, I'm going to put this one in pink. That is the graph y equals 2x plus 1. Now, I see the y-axis, so I can use the slope and the y-intercept very quickly to graph that. You know, so we can just start at 1, go up 2 over 1. Do I land? Am I allowed to stand on the border? I am not. Just look at this symbol. That means open circle for that border. So when I go up 2 over 1, it's open. Now, I'm allowed to travel in the left direction, so I could also continue my line by counting to the left 1 and down 2. So then make that portion of your graph. Okay. Now I'm going to make the second piece here in blue. Unfortunately, it occurs on the right side of the line. So if I did the whole start at -3, count up 1 over 1, up 1 over 1 sort of thing, I would have to really just graph the line on the actual, you know, I would have to erase some of it. So what I'd like to do for the graph that's over here, and this says greater than or equal to 1, so why not for that one, let's just plug in some numbers that are greater than or equal to 1. So 1 and 2. 1 minus 3 is -2. 2 minus 3 is -1. All you need to graph a line ever is 2 points. Those 2 points will be in the region I want. For that line, am I allowed to stand on the border? Yes, because it has that equal to. And so that point, 1, -2, will be a closed-end point. And then 2, -1 is going to be on the correct side of the graph. And so here is that portion of the line. So you will have a very simple piecewise function, nothing fancy. It'll look similar to what you see. There are two linear functions that are stopped by a particular value of x. Okay. Any questions about our piecewise function number 12? You are going to have to graph an absolute value function like we see for 13. An absolute value function is that v. I have not put any kind of thing to stretch it, so it has just moved nicely. So instead of being at 0, 0, you know, our v looks like this, it's going to move to the left 2 and down 3. So we're going to move that to the left 2 and down 3. To verify that, just like the square root we began with in our graphing section, if you set x plus 2 equal to 0, you do get -2. That kind of tells you where the starting value is. Now, from the symmetry of a absolute value function, you know it's at v. We know if -2 is like the point of the v, the vertex of the v, if you plug in something to the left of it and something to the right of it, you'll get where both sides of the v are heading. So that's my strategy when I do the 3 points accuracy for an absolute value. If you plug in -2, you get the absolute value of 0 that has moved down 3. That's what that -3 is going to do. If I do the absolute value of 1, when I plug in -1, I get 1. 1 minus 3 is -2, and you should get -2 here. The symmetry should work that those two should match, or you've done it wrong. Either you chose the incorrect middle point, or, you know. So anyway, let's graph those. And I apologize, my line kind of sucks where I put it, but we'll figure it out. Anyway, so at -1, let's cut these in half. And your graph paper might be all messed up anyway. So if you mess with the graph paper, I'm assuming they're counted by ones unless I've told you otherwise. If you change the scale on my graph paper on the quiz tomorrow, please mark what you're writing it. You know, if you break it down differently, that's okay. Just make sure you indicate what you did. Okay, so at an x value of -1, we're down at -2. At an x value of -2, we are down at -3. And then at -3, we are down at -2. And so our graph looks something like that. Okay. So that's what your V looks like. You shouldn't have any trouble graphing those, hopefully. Now, for number 14, this will either be a squared or a cubed tomorrow. Make sure you know how to graph a parabola. Just look at your power there. If it's a squared, make a U. If it's a cubic, like this one, you know, it's going to be like that. Now, what do we know? Well, that inside should move it to the right. So normally for a cubic, I plug in -1, 0, and +1. So if that moves those points to the right, I'm going to plug in 0, 1, and 2. You want, even for a parabola or for a quadratic, you want this to be the center based upon where does that equal 0. Well, x minus 1 equals 0 at 1. So let's plug those points in so we can get a good idea what our cubic is doing. Now, hopefully you realize that this is going to flip it upside down. So instead of being like that, it's going to be like that. And then this should move it right, and this should move it up. So you can do those transformations if you want. You graph whatever way you want to do it. Okay, if I plug in 0, I get -1 cubed, which is -1, but there's a negative on the outside, which is +1. And so +1 plus 1 is 2. I know I said that fast, but if I plug in 1, I get 0. Cube, that gets 0. The opposite of that's still 0, so that's +1. And then if I plug in 2, I get 1, but the opposite of that's -1 plus 1 is 0. So at 0, I'm up at 2. At 1, I'm at 1. Now remember, that's our little center point. And then at 2, I'm at 0. So the left arm goes up, as we predicted, and the right arm goes down. So there will be either a parabola or a cubic on that, in that spot tomorrow. Any questions about that one? Okay. For 15, since I graphed a cosine, I bet you can probably expect a sine, but it's either going to be a sine or a cosine tomorrow in the spot where 15 is at. Remember the 5 x's that you want to plug in for any sine or cosine is wherever the inside will be equal to 0, pi over 2 pi, 3 pi over 2, and 2 pi. Now remember that the cosine starts at 1 and the sine starts at 0. The cosine starts at 1 and the sine starts at 0. So this technically is going to be the y value I just talked about, 1 or 0, times 3 minus 1. Okay, so the good values for the cosine, it starts at 1, then goes to 0, then goes to -1, then goes back to 0, and then goes back up to 1. So you'll notice that I just wrapped the 3 minus 1, the 3 times that quantity minus 1 around those values. So if you look at those values, we've got 1, 0, -1, 0, 1. That's what the cosine does. 1, 0, -1, 0, 1. And I've just wrapped that 3 on the outside and that -1 around that. And, simplify it. Okay. So put your midline on. I did not change the x values in any funky way for the one on the quiz, just basic x values. So let's go 1, 2, that's a pi, 1, 2, that's a 2 pi, 1, 2, that's a negative pi, -2 pi. There we go. I was trying to make the amplitudes match. And then it comes back up, and then it goes up, comes back down. And then down and back up, and then up and down. So some things to remember about symmetry. If a function is even, when you plug in -x, it goes right back to the way it started. It's going to have y-axis symmetry. If a function is odd, when you plug in -x, you get the opposite of the original, and it's going to have origin symmetry. So we are going to just be doing the -x test for both or all of these functions, and we're going to see, does it go back to the original status? Then it's even. Is it the opposite of the original? Then it's odd. If neither of those things happen, or some pieces change but some pieces do not, then we'll just write neither, and we don't care about the symmetry. Okay, so let's take a look at 16. So we're going to plug in -x, and you'll notice we just get a brand new function. It's not the opposite of the original because we can't take that negative out. What that does is that flips it across the y-axis. So instead of our square root looking like that, we actually get a square root that looks like that. So this one's a neither. It's not even, it's not odd. Who knows what the heck it is, okay? Now, for number 6, when we do the negative x test, because the negative x only goes into a square, it goes right back to a positive again. So it's even, and it has y-axis symmetry. So that's a version of a function with y-axis symmetry. So we're going to do that same negative x trick for all of these. So if we plug negative x into this one, the negative switches the sign of every single term. So you'll notice it is the exact opposite, or like we multiplied by -1. So this is a version of an odd function that has origin symmetry. So now we have seen a version that wasn't anything, a version that was even, and a version that was odd. So now that square instead of that cube really changes things, because for k, when we plug in the x as a negative x, the first piece changes. No, I'm sorry, gosh. The first piece becomes a positive, or remains a positive. The second piece becomes a positive. So if we compare that back to the original, this piece here is the same as it started, but this piece is the opposite what have started, and it either has to be one or the other. It can't be a combo of those things. So this is a neither as well. So that is one last example is J. And if we plug in a negative x, part of our equation changed. The it doesn't want to do anything. Go down there. Part of our function changed, that x changed, but the 1 does not. So this is a neither. So either everything changes or becomes the opposite of what we started with. That's an odd function with origin symmetry. Or everything goes back to the original form. That's an even function with y-axis symmetry. So those are some symmetry examples. So your quiz is going to look very much like what you see here. So there you go.